Hello 143 class, this is a homework example from section 2C. This is problem number 6. Now it says in here that 8 turns of a wire wrapped around a pipe with length of 60 inches. What I'm doing here is I've changed it from a pipe to a rolling pin just so you can kind of visualize what's going on. But imagine a rolling pin. Okay, and the rolling pin has dough in that pattern that they're talking about, that wire being wrapped around there. So the wire's wrapped around there, and that's our dough on our rolling pin. But also just imagine if there were some, let's say maybe some red icing on this side of this rolling pin. Alright, so there's red icing just on the very edge of the rolling pin. Now, you take the rolling pin and you start rolling it this way. Now, as this rolling pin starts to move, you're going to leave this trail of red icing behind. So the rolling pin starts to move, and that trail of red icing from that upper edge starts leaving that trail like that. And then what's going to happen with this dough is it starts to come off of here. As it starts to roll away, the very edge, the one that was touching the upper corner, that part of the dough, let's make the color a little darker so we can see it. Let's make this yellow color. That part of the dough is going to start coming up this way, and the further and further and further you roll this thing out, the more and more and more dough is going to come off of this thing as you go. All right, and the more and more and more that icing is going to come. Now we're just imagining that the icing will never completely, go away. So we end up with that shape, and you can kind of see what's taking place as I'm rolling this thing out. Till finally, when I roll all the way over here, and all of the icing has come off, and all the dough has come off. All right, what do we end up with? Or what we're going to end up with is a right triangle. Okay, and then there's our dough, and one side of that right triangle is going to end up being the excuse me. One side of the right triangle is going to end up being the rolling pin. So let me connect it the right way so you can actually visualize it. So this upper part of the rolling pin down to that very edge where they first came together. And we end up with, like I said, a right triangle. Now, what are the side lengths of this right triangle? Well, the pipe, which again I'm visualizing with a rolling pin, the pipe is 60 inches long. Okay, this red part, the icing, came from that right edge. Every time that thing circled over, like from one part of it all the way around until it got there again, that was the 4 inches. That's the circumference. Okay, the circumference is the distance around these circles. So once we went around one time, that was 4 inches. Well, it says 8 turns to get all this dough off, or which would be the wire. So 8 of these 4-inch circumferences, so that's 8 times 4. So this red side is 32 inches. All right, and what are we trying to find? We're trying to find how long the wire is, which again, think of the wire as that dough. That's the hypotenuse of our right triangle. So if you remember the Pythagorean theorem, it says a squared plus b squared equals c squared, where a and b are your two shorter sides and c is your longest side. So there's our setup. We just need the Pythagorean theorem. So this would be 32 squared plus 60 squared equals c squared. Okay, if you use a calculator and square 32 and 60, add those together, and then I take the square root of both sides. So c is the square root of that, which ended up being 68 inches. So that was a way to do it. If you clicked on view an example, it would not show you this way. I think this way is easier than the way that they show you on view an example, but you have to have that visualization. You have to be able to visualize what would happen if we unrolled this thing in that manner. And this would be the toughest part to kind of visualize, because it doesn't mention anything about how to directly use that circumference. So anyway, you end up with that right triangle with the hypotenuse being the wire whose length you're looking